Hello and welcome. I'm continuing to wade through the deluge of cases from last Saturday. This is the one that that I just kind of caught a glimpse of on the stream that I was particularly excited to do because it's about solving Rubik's cubes. Um, that's all I really know about it so far, but that is enough to make me think it's going to be quite a hard case. It's called Cube Cubed, but also Cubo Tres is Laennder's company, I think. So sort of Easter egg there as well. Okay, I will say I heard from some people who were there on the day that a sort of probably winning strategy here was a fairly manual approach. Even if it ends up taking me longer, I am determined not to take a manual approach on this, but we'll see what that ends up looking like. All right, let's dive on in. Start my timer. Rubik's Cube is not just a simple object. It's 43 portable laboratory of logic and probability, waiting a few colors and faces. Yes, I know the basics of the Rubik's Cube, 6 faces, colors. Cube is a 3D object, Excel is 2D to make your life easier. I swear, we've provided 24 two-dimensional diagrams in the perspective sheet. 6 faces times 4 rotations. 24 two-dimensional diagrams. Oh, yes. Okay. Each Rubik's Cube has 3 types of pieces. Yes, I know that. Face piece coordinates. In the frontal 0-degree perspective, each face piece aligns with the grid. For example, row 1, column 1, 1, 1. The face piece code is defined as color code plus coordinate. For example, blue face row 2, column 1 is B21. Pay attention, the grid rotates according to the perspective angle. If the frontal face is not a 0 degrees, the coordinates will not be aligned. Oh my word. Okay, rotating the cube face. Each of the 6 faces of the cube can rotate 90 degrees to the right, clockwise, 90 degrees to the left, counterclockwise. Face rotations are noted using the color code of the face being rotated in the direction of rotation. For example, this. Okay. When a piece is rotated, all its face pieces rotate as well, since they belong to the same piece, including face pieces of another face different. Yes, I understand that. Centerpiece determines the color of the cube's face. It never changes position. Yes. So if the centerpiece is green, that is the green face of the cube. All questions start from the cube in its original position. In the details sheet, you'll find illustrated examples that may complement the explanations. Oh my word. Okay. Return the color of the given face piece. Okay, well, we're starting light. I guess I'll hide the feedback. So let's just name this calls, and we should just be able to say XLOOKUP left of this in calls, returning from calls, match mode, regex. We just see white, green, orange, red, blue, and yellow. Yes, there's no repeat letters, I think. Let's just check that. Left this equals this. Yes, good. Fine, happy days. All right. For level 2, consider the white front perspective with the given rotation. Okay. Oh, now I start to understand. Okay. So in other words, right, if you're looking at white at 0 degrees, right, then the one on the left is green and the one on the right is blue. And the top is orange and the bottom is red and the opposite is yellow. Okay, okay. Let's say that I kind of get that. Consider the white front perspective with the given rotation. Return the color of the indicated face according to the perspective. Okay, so I think this is just going to be, let's add something else in here. Let's insert here. Let's shift this down because I want to keep my colors together. And then let's do this and this. Okay, and then we're going to name this. I guess I'll call it per for perspectives. And have I imported my lambdas? I don't think I have. Nope. So let's import my lambdas. And then this should just be TLOOKUP in perspectives. The row is going to come from this. The column is going to come from white and this. That gives me O, and then I want to XLOOKUP that in calls, returning from calls, regex. Okay. Oh, there's an NA there. 0 degrees front. What? Whoops. Yes, 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 yes. That's not right. So let's insert another row here, and let's cut this, put it down there. That's better. Okay. For level 3, you will receive a perspective, front face, color, and a rotation. Okay. So, and I think this is basically the same thing except different, obviously. Okay, so this should say green, and instead of W, so this has to become text after a space, and this can become left of this. Okay, if that gives green, and I think we're happy there. Level 4, you will receive a face piece and a rotation move. Rotate the same face of the cube in the direction indicated by the move. After the rotation, return the code of the new face piece that now occupies the position previously. Okay. So the color is irrelevant for now. So let's just do sequence, comma 3, and wait, yeah, no, sorry, sequence 3 and sequence comma 3. Okay, 1, 1, 2, 1, 3, wait, yes, okay. So then there is a combination of flip and transpose that amounts to a 90-degree rotation, and I'm darned if I can remember what it is, but let's try. I think it's flip horizontal. If I was a better visual thinker, I would just know, but I don't. Okay, it's not that. Is it flip vertical? Wait, hang on, sorry. No, this is right. 3, 1, 2, 1, 1, 1. Yes. 2. No. Wait, what? 3, 1, 2, 1, 1, 1. 3. What? Shouldn't this be 3, 2? 2, 2. I'm very confused right now. I think this might not be right. Well, easy way to check. Let's copy this picture, crop it a little, and then actually rotate it. And then we will soon find out what's going on here. So done cropping, rotate. So it should be 3, 1, 2, 1, 1, 1, 3, 2, 2, 2, 1, 2. Yeah, because this is not right. 3, 3, 2, 3, 1, 3. Okay, the rest seems to be right. And in any case, it does agree with this. Okay, so that's a rotate. So let's just, whoops, all right. So now I'll call this ST, and I'll make that an input. And so we'll call this, I guess, clock. And let's see lambda. Wait. Oh, sorry. Generate lambda. Wait, what? Huh? Oh, sorry. Maybe I just need to be selecting one cell. There we go. Save lambda as. Okay. That is clock. And I could be more creative, but on the other hand, maybe I won't be if I just say clock, clock, clock. It's definitely the dumbest possible way to do it, but I think it works. So I'll call that anti-clock. And save lambda as. It'll do. It's ugly, but it'll do. Okay, so then, sorry, wait, I actually want to keep that. So then, what rotations do I have to deal with? Counterclockwise and counterclockwise. Okay, so equals to call of this, equals to call clock of this, and equals to call anti-clock of this. Okay, so then this is a clockwise rotation, and this fella here is an anti-clockwise. Oops, sorry, an anti-clockwise rotation. So then, I think I just want to. Yeah, let's just try it first. So T lookup sorry, no, I just misspelled. Sorry, equals dlookup. So we're going to look up in here, lock, oops, lock. The row value is going to be mid of this 2, 2, and the column value is going to be that, and that indeed gives 1, 1, and then I just want left of this and that. Okay. I feel like we're just dabbling here, but this is going to get monstrously hard soon. For level 5, you'll receive a face piece and must return the type of piece, center, edge, or corner, and the color codes that make up the complete piece. Okay. Oh. Oh my. Oh my, oh my, oh my. Okay, so I guess this is what I want. I want to go here. I want to, ooh, I don't like that being merged. Never mind. Okay, so for a given color, let's just X match this against this, but only the first column. And match mode regex. So you get 16. Uh-oh, that's not good. And then 2 1s. That's very not good. Oh, sorry, wait. Oh, right, we've got some empty rows. Silliness going on here. So let's cut that, put it there. Crap, but we've still got, yeah, something's not right. Oh, right, sorry, yeah. So it just has to be not regex mode. I want wildcard mode. So I want to match this and star. Okay, so now we got 1, 16, 30. Yes, that looks more like it. Okay, so then I want what? I want to, I guess I want to offset from this. Actually, I don't really need the middle bit. Let's get this. And then I'll just manually move it up 1 more because I don't want to get into the merged cells there. So offset from there by X match the color, which I'll get in a second, and star against all of this stuff, but only the first column, lock, and wildcard match. That -1. Okay. And then it's going to be the left of this thingy thing here. Yeah. What's going on here? Get me back. Oh, sorry, I'm back. What am I doing? Okay, so G204. And, oh, sorry, yeah, and 0 columns. Hooray! Okay. So then I want to get rid of right face. That label is not helping me. So let's just search here. Okay, good. Now that's empty. Happy days. These are 0, these are blank. That's not super helpful, but never mind. So what's the best way to do this? Well, one option would be to say neighbor op this range of 1 function concat, or better yet, neighbor op left of this 1 concat. Okay, I don't love the 0, but yeah, that's, is that working? Yes, because I just want the unique colors. So then I guess I can do better than that. I can say lambda orangey to call RNG3 unique, and then concat. Will that work? No. Okay, well, I've still got the 0, but I guess I can just substitute out the 0. Okay. think that's good because now that will tell me this. Oh, and actually I should sort them because then that will sort this. Then it'll give them to me in the right order. Okay, so then I want to let neighbors be all that stuff, and let's return 1 for a second, and then all of this I want to put in here. NB calls can be neighbor op left of NBs. This is really the neighbors, the range. This is the neighbor colors. So then return NB calls. Okay, so then I want to XLOOKUP this in toCall of RNG, returning from toCall NB calls. Perfect, and then so this is calls, and then I want to say, I guess choose len calls. So if it's 1, it's a center. How do we spell American or British spelling? American. If it's 2, it's an edge, and if it's 3, it's a corner. So that, and calls, and that is some formula. And this is still, we haven't come to any of the hard stuff yet, I would say. False. Bother. Oh yeah, there's a space at the end, fine. Tricky format. Okay, there we go. Not convinced that I'm building this in the right, oh dear. Yes, I didn't block the starting point. Okay. All right, level 6. For level 6, you'll receive a face piece and a rotation move similar to level 4. However, now the rotation move also indicates which face must be rotated. Yeah, okay. The code of the face piece now occupies this position. So this is the real sort of meat of it now. Level 7, you receive a sequence of moves and the color of a face. Right. Okay. Oh, mama. So. All right. I'm torn over whether to be like vaguely tactical and go do bonuses now. I think I just want to be pure and try it, even if I'm not sure I'm going to get there in 30 minutes, but I don't really care that much about that. Okay. So, for each rotation, yeah, I think I can do this. I think I can. So I think I just want to work with this one, not any of these. Okay. So then actually this shouldn't be that hard then, should it? Okay. Let's make a start at least. First thing, I want to get rid of that and that and that and that. No labels, please. And then I want to call this, all of this, 3. Okay. Let A be that and filter. Missed a comma. Filter A, where A is not blank. Is that what you're? Okay. So now I've got 54, which is the right number of things. Good. And I guess I'd like to sort that. Would I? No. Would I? Maybe. Yes, I would like to sort that. Okay. So then there are 12 types of moves. And what they do is they pick one of these 6 and then they pick a direction. So this isn't that bad, is it? I think this isn't that bad. I'm afraid to say that because it sounds like famous last words, but I think it isn't that bad. So if I say clock of this, I think that does it. So yeah, all right. So starting position is just left of all of that. Everything is its own color. Then if there is a move, the color that ends up in W33 will be the, so if there's a clockwise move, will be the color that starts off in R33. So let's just do one slowly first. So let's say X lookup this location in toCal of this, returning from toCal of this. Okay, and then X lookup that in this, returning from this, and we're going to say if error, then this. And then we'll check if this, so let's X lookup all of this in here, returning from here. So, no, that did not work because I must have done it the wrong way around. Okay. Again, if I was a more clear visual thinker, I might be able to do better than let me just try doing it the other way around, but apparently I'm not able to do better than that, so that's fine. Okay, so we've got the red goes up here, white goes up there, orange goes down there, yellow goes across here, blue stays all in there. Then I think that's it, isn't it? Yes. Okay. So some of these are going to now become constants. So this is, I'll call it pos. So we'll always look up in pos, but then we're going to be returning from previous. And then we need a way to systematically get that. Okay. And it's actually working. Oh, wait, sorry, shit, no. It's not working because I need to know more. I need to know this. Okay, fine. So let's try the more general version then. So let's say that instead of that, we give it that, and instead of this, we also give it pos. So now we've got R13, R33, R23. Yes, good. All right, so then let's I guess just keep it that way, except that this is now going to be prev and prev, and this is going to be what? Okay. Okay. I think we're good here. So now I need to offset from, and let's just give this a name, it'd be helpful. Okay. I'll call this pair 1. I'll call this, after I unmerge the labels, mu, bring it just to this one, and then I'll call this per lab for labels. Okay, so then I want to offset per 1 by x match left of this, and a star against per lab, wildcard match, -1, yeah, and 0. Okay, good. So then let cent, we'll call it, be that. then we want to say XLOOKUP. Hang on, sorry. No point in rethinking through this because I have written the bloody formula already, so let's just go get it from here. So from that into the clock version, yes. So this, wait, C109 hash, is that pause as well? Yes, it is. Okay, fine. So XLOOKUP pause in to call of sent, turning from to call of if right of this equals, I just want to grab that symbol, that is clockwise, then clock, otherwise anti-clock of send. Okay, so that's the X lookup, and let's budge it over for a second. Good. And for now, we're just going to say if not found, pause. And actually, we don't even. This one I think is simpler. We can just X lookup this in that. And it'll give me. Oh dear, it does not. Okay, I'm going to cut out of the live solve here because after this, things started to go wrong in a great many ways. So first of all, I saw that I was getting W31 instead of Y31, and I, again, was not like sufficiently confident on the order of these arguments that I persuaded myself that that meant I probably needed to swap these arguments, which did change the answer to being correct. But if you think about it, that's like looking up in the version after the twist back into the version before the twist is basically the equivalent to doing the lookup the right way around but reversing the direction of the twist. So what I was doing was turning a solution that should have been doing a clockwise rotation into a solution that should have been doing an anti-clockwise rotation. The reason I needed to reverse it was because actually this part was not working. So the right of this, well, we can just do it here. This is one of those weird like length 2 emojis. So I guess if I say write this 2, that would, yeah. So this is a 2-character emoji, and write did not behave with that. And so this test, are we in the clockwise orientation, failed. And so it was doing an anti-clockwise rotation. And so I undid that by swapping them, which meant that I got this one right and got any clockwise rotations right because I was reversing an anti-clockwise rotation, but the test was failing on both directions because the right character was never equal to this thing because this is 2 characters at the right. And so, yeah, I didn't have a working solution there, and then things started to go much more wrong because going from there to level 7 involved complicating things more, let's just say. And also at some point my file crashed and I couldn't recover it. I had to rebuild it. So where I thought I was like 5-10 minutes away from a finish here, at the point I cut out of the live solve, it ended up taking me like 40 more minutes to finish the solve, not including the time I spent rebuilding the file with the camera off. And that's fine. I don't mind, putting up videos of me doing badly, but I felt like it didn't really do justice to how nice a problem this is, to have me floundering around like that. So instead, I'm just going to do a new finish from here. So first things first, instead of looking for the right of this, we're going to change this around to say isNumber search for that in this, close, and now that does get the right answer. And if I fill it down, that behaves. Sorry, I still have my old answers in here. I'm just going to I'll copy that as values and then get rid of that. And there's still something over here as well, so I'll get rid of that too. Okay, so once you have this, you've got, like I actually started off putting in pause the list of all the positions in here, and then if not found, pause, and that would give you the kind of the translation for the whole 54 starting positions in the in the position column to say, what ends up in the position that starts off with each one of these. But, sorry, undo that. But if you want to then apply subsequent changes, you can't just go from pause. So let's break it down. First thing, rather than working with the center and the rotation of the center, you have to translate the center, which is looking over here at, like at this one, for example, at the things that were originally in the center. You have to first translate the center into what is in the center now, or what is in the center in the previous turn. So let's just say cent prev can be xlookup cent in pause returning from prev, and if not found, blank. And then we'll work with cent prev instead of cent, and down here. And then we can look up the previous in this, returning the previous. So what this is basically doing is taking a rotation and applying it to a starting position, which we're calling prev. So now I can basically make this into a lambda to say lambda prev and rot, and then we'll replace this with rot and this with rot, and then that will transform a previous configuration into a new configuration, and that is, if I've got it right, should be all I need to solve this. So in level 7, we're basically applying a series of moves, and then to make sure you've got it right, you output the answer in the form of what are all the colors on one particular face in the order that they appear. But once you've got the full list of what's in each position, each of the 54 positions, that last part is easy. So we're going to reduce. We're going to start from pause, in other words, start from everything in its initial position. Then the array is going to be text split of this by a space. And then the function is going to be that function that I just copied. And that doesn't work. Oh well, oh well. Let's see, what have I done wrong? Lookup prev into call send prev to call if is number search for clock anti-clock of send prev. That all seems fine. So what's going wrong? Well, first things first, let's try going one step. Take from this by 1. What the? Oh, okay, I seem to be missing a... I have an if not found prev. So let's just see. It does seem like we're getting, yeah, 21, which is, I think, the number in, yeah, so it's 9 in the face plus 3, 3, 3, 3, yeah. It's 21. I'm just getting the pieces that move for some reason. But I've got an if not found, so what's the problem? That's really weird. Okay, well, let's just take our starting position and let's take our lambda and let's apply that lambda to this starting position and to text before for this with a space. Super weird. Okay. All right, then let's bring them into the let because that makes it easier to debug. Actually, wait, hang on. I think I can robot that. Let's try. There's a lambda to let command. Yeah, lambda to let. That's what I want. Much better. Okay, so now let's cycle let steps. So this is prev, which is just the starting position. Good. And the rotation is that. Good. Then cent is this, and I got something hanging on up here. Get rid of that. So these are the center positions. That looks good. then I have to go back here again, I guess. Cycle that steps. Cent prev looks good. Okay, getting confused now. Name this out. And give me to call cent prev. Fine. I'm very confused right now. Okay, so these are not, there's no ignoring going on, so they should be definitely exactly the same size, but let's just check that. They are the same size. Oh no, it's the stupid XLOOKUP error handling. It doesn't like to handle arrays. Ugh, I hate that. Hate that. So I've talked about this before, but just brief explanation, because I guess anytime something kills me on a live solve, it's worth talking about why. So let's just say we have 1, 2, 3 returning from 4, 5, 6, and let's say we have sequence 6. So if I said look up this in here, returning from here, and if not found, return the value, you would expect it to return 4, 5, 6 as matches, and then 4, 5, 6 as non-matches. But it doesn't. If not found this. It doesn't. It gives this value error because it's only able to handle a single value here, not an array the same size as your input array. So you have to instead say if error xlookup this in this returning from this, then this. Sorry, close the bracket there. So that's in the if error, and then it behaves. Ugh, that's annoying, but anyway, fine. Okay. So now we come back over here. We change this into an if error, and then close the bracket here. That behaves. Now we can get rid of the take, and hopefully it's all going to cooperate. Okay, so that gives us the what ends up in each position, and we want to figure out what ends up in the original positions of the white face. So we're going to say filter this where left of pos, which is the list of positions. So whenever the left of that is white, that's one of the positions on the white face. So whenever left of that is equal to left of this face input here. That's what we're interested in. And then we're just interested in the color, so we'll concat left of those. And that, sure enough, works out just fine. All right, so I went off the rails a little bit, but not as badly as I did on my live solve. Anyway, let's do the bonuses. How many face pieces are there on the Rubik's Cube? So there's just 6 faces times 9 on each face. What is the color of the right face when the blue face is on the left? If you know your Rubik's Cube, you'd immediately say blue is opposite green, but you can always just come look here. Look for any one of these where, I mean, you can kind of tell from any one of these diagrams that blue is opposite green, but here's one where green is on the left and blue is on the right, or whichever, maybe you need it the other way around, but anyway, you get the idea. Or you can go to the to this thing up here and look for one where green is on the left and sure enough blue is on the right, or the other way around, whatever. Anyway, okay, what is the code of the yellow face piece of the piece composed of yellow, red, and blue? All right, so let's find one where yellow is the centerpiece. Here it is, and the one bordering on red and blue is this one, Y31. How many different arrangements can a face of the cube display when all 9 face pieces are the same color, but not all face pieces are in the correct position? So this one broke my heart because I got the main piece of the logic exactly right. The main piece of the logic is corner pieces can only end up in corner pieces, edge pieces can only end up in edge pieces, and the centerpiece only ever stays in the center. So there are 4 factorial ways to arrange these 4 pieces independently, and there are 4 factorial ways to arrange the 4 corner pieces independently. So I confidently said fact 4 squared and moved on, and then when I checked my answers later, I realized that was wrong, and it's because I got the hard part right and the simple part wrong. Not all face pieces are in the correct position. So there are 576 possible positions. In one of them, they're all in the correct position. So It's 575. Right, and finally, starting from Rubik's Cube initial position after performing this set of moves, which face piece codes come to occupy the original position of 031 after each move? Separate the codes with a comma. So this is basically the same as the level 7 thing, except that we need to accumulate all the positions instead of just keeping the last one. So let's take just the reduce from here. And I guess let's bring it out here and work with a little bit of space. Okay, so we want to start from pause, but the thing we want to text split is over here, which is this. So let's say text split of that. And then at the end, we want to each stack prev with this and a closing bracket, and then we need to replace any references to prev with just take the last column of prev. And there are a few, so here's one, take prev -1. Wait, no, that one we keep, this one change, and this one we change. And that should then give us the initial position plus the position we get to after 4 moves. So we're going to drop the first one of those because we don't want the initial position, we just want where it ends up after each move. So drop the first column, and then we want to filter this. We want to know what ends up in position 031, I think. Yes, 031. So we'll say filter all of that where pos equals 031, and then we'll text join with a comma space, all of that, and cut that and bring it over here. Hooray! All right, so yeah, like I said, I went a bit off the rails in my life solving it. It ended up taking me ages, but I feel like that does a little bit more justice to the fact that, not to suggest that it's easy, like I went off the rails because of some technical issues, but mostly because wrapping my head around, like, you know, if you had this plus this rotated 90 degrees as the original positions and what the original positions shift to, but then you also have what was previously in that thing. I got so confused as to what I should be looking up in what. I think maybe overly confused, but in any case, I got very confused. It took me like 25 minutes to complete that formula. That, you know, without any mistakes, could have been got from my level 6 formula in like 3 minutes. So it is hard, but it's also capable of an extremely elegant solution, I think. So yeah. Bottom line, love the case. Really clever, really neat. That's all I got for today. Thanks for watching. See you next time.